All right, we're going to talk about polynomials. In this video, it's just going to be the important characteristics of a polynomial that will eventually help us graph the polynomial by hand. So a polynomial function is going to be a continuous function that ranges in degrees, right? So it can be an infinite number of degrees. We have a few of the common ones listed here. So the first one is the constant. Notice that there is no x, which really means it's just x to the power of 0, so the degree here would be 0. If we're looking at a linear function, it's just x, which is really to the power of 1, so it's a degree of 1. A quadratic, it's got the squared, so it's a degree of 2. Cubic is a degree of 3, and a quartic is a degree of 4. We will be going up to a degree of 5 in here. But these are the common ones. These are their standard function equations. You can have things added to them, some transformations as well. So when talking about end behavior, end behavior is essentially what's happening at the ends of the graph. So as x is approaching negative infinity, as x is approaching positive infinity. When we look, there are two things that we have to look at specifically. The leading coefficient. Is that number positive or is that number negative? And that's going to affect the right behavior of the graph. When we look at the degree of the graph, whether or not it is even or an odd number, that's going to determine the left behavior. So we're going to create a little chart so that we're understanding what is happening at those ends. So if the function is even and x is approaching infinity, right, an even graph is kind of like the quadratic, right? It's the U shape. So as x is approaching negative infinity there, so if it's going to the left, y's are approaching positive infinity. Notice that both of the end behaviors are going the same way. So that means as x is approaching positive infinity, y is going to be approaching positive infinity as well. They're both going in the same direction. Now if we take that and we make it negative, right, we're just going to flip it. So that means as x is approaching negative infinity, the y's would be approaching negative infinity. As x is approaching positive infinity, y's would still be approaching negative infinity because with even graphs, the end behavior is going in the same direction. Okay, so an odd function, it's got that graph that kind of does one of those things. I'm not the greatest at drawing it. So as x is approaching positive or negative infinity, right, the y's are also approaching negative infinity. As x is approaching positive infinity, the y's are also approaching positive infinity. Okay. Now when we flip that graph, as x is approaching negative infinity, the y's are going to be approaching positive infinity. Okay. As x is approaching positive infinity, the y's will be approaching negative because it's going to be opposite from its original graph. I'm also going to draw some arrows on here so we know which way things are going, right? So with the positive and even, both ends are going up. With the even and negative, both ends are going down. Odd, it's going down and then up. And then here it's going up and then down for our end behavior. That's what it's doing at the ends of the graph. Some other important characteristics that we're going to need to know are the x-intercepts. Okay, they're going to have at most n number of intercepts. Okay, now I say at most because x-intercepts are your real solutions. These are real numbers versus complex numbers. Okay, if we're talking about zeros, then we're talking about having n amount of zeros, and this is always and indefinitely going to be true because it's including the complex numbers. So the x-intercepts are just your real numbers. Where the zeros include your complex solutions. Your y-intercept, right, is going to be where the function crosses the y-axis, which means that you plug in 0 for everything. So in a function, maybe you got x squared plus 2x minus 1. This extra piece on the end is always going to be your y-intercept. Now, if there is no number there, right, then it's just 0. Your relative extrema are going to be n minus 1, where remember, n is standing for the degree of the function, which is your highest power shown on the function. So let's take a look at finding all of these characteristics. We've got x to the third, so it's a degree of 3, which means it's an odd function. The leading coefficient is 1, and it's positive. Possible extremas, we take 3 and we subtract 1. We get 2. The end behavior, okay, so now this is where we're going to look at our degree and our leading coefficient. As x is approaching negative infinity, this is an odd function and it's positive, so that means y is also approaching negative infinity. As x approaches positive infinity, y is approaching positive infinity. The y-intercept, right, there's nothing extra being added on, so it's 0. Please remember y-intercepts are points, so the point is 0, 0. The number of possible zeros is 3. We're going to talk about how to figure out the possible positive values and the possible negative values in a couple minutes here. Okay, now to find the actual zeros, we're going to talk about how to do long division and synthetic division in this unit. We're not there yet, so all of the problems so far, we're just going to use factoring if we can. And factoring is a great method if it's available to you. If you cannot use factoring, we're going to then we'll talk about the other methods at that point. So here, I can factor out an x. So I get x as x squared minus x minus 2. So I still have my x on the outside, and then I've got x minus 2, x plus 1. And then I take each of these and I set them equal to 0. So x equals 0. And x minus 2 equals 0. And x plus 1 equals 0. And then I write these as points. So I've got 0, 0 here for the first one, which does not count as a positive or a negative solution, so please keep that in mind. I've got 2, 0, and I've got negative 1, 0. Okay, those would be my 3 points there. And this was a degree of 3, so I have found all of my solutions there. We'll give it one more shot here. The degree here is 4, so it's even. The leading coefficient is negative 2, and it's negative. Okay, the possible extrema are going to be 4 minus 1, which is 3. And behavior, this is an even graph, so they're going to be going in the same direction. I just have to determine whether or not it's y is going to positive infinity or negative infinity. And since it is a negative leading coefficient, both of our y's are going to be going to negative infinity. Y-intercept, again, here we do not have anything extra, so the y-intercept is 0, 0. Possible zeros is 4. Actual zeros, you got to factor some stuff out, so I'm going to factor out negative 2x squared, and that's going to give us x squared minus 1. So that's negative 2x squared. This is a difference of squares, so x plus 1, x minus 1. And then again, you set each of those equal to 0. You'll have 1, 0, 0, 1, or negative 1, 0, and 1, 0 as your points. Now we've got a negative 1, 0, and a 1, 0, and then 0, 0. That's only 3, but we said that there should be 4. Notice that the negative 2x is squared. So that means we're bouncing off of 0, 0. We wouldn't go through it like we normally do with a 0. It would just touch and move on, and that actually counts as 2 roots. So then we actually do have all 4. Okay, so the last thing we're going to talk about today is Descartes' rule of signs. Um, and we can use Descartes' rule of signs to find the positive zeros and the negative zeros of a function. Now, we can't find the exact values, but we're finding the possible amount of values. And once we get into synthetic division, we'll talk about how to actually find and derive those roots. But today we're just going to talk about how to find the possible positive solutions and the possible negative solutions. So the possible positive solutions, we look at f of x and we decide how many times the sign changes from positive to negative. So technically this 3 out in front is positive. So we go from positive to negative, so that's 1. And then we go from negative to positive, that is 2. And then we go from positive to negative, that is 3. So for the number of solutions, or zeros, we could have 3. Now, there's an or. So if we have complex solutions, they always come in pairs. There's always 2 of them. So if we take 2 away from 3, we get 1. Now we cannot go any further because if we take 2 away from 1, we're in the negatives. Okay, so it's just going to be 3 or 1 as our possible positive solutions. Now to get the negative solutions, we have to find f of negative x. So we're going to plug in negative x everywhere we have an x in the original equation. So we've got 3 negative x to the third minus 5 negative x squared plus 6 negative x minus 4. We're only looking at this equation, so we are no longer looking at that equation at the top. We're just looking at this one. Now, when we take a negative number and we cube it, right, it stays negative because that's negative times a negative, which is positive, and then we multiply by another negative. So this 3 negative x to the third is going to be a negative number. Now, when we square a number, right, that's a negative times a negative, so it becomes positive. So this x squared here is positive, and we're multiplying it by negative, so it stays negative. Negative x times a positive 6 gives us a negative 6x, and we've got a minus 4. So if we look here for sign changes, we go from negative to negative, right, so that's none. We go from negative to negative, that's also none. And then we go from negative to negative, so there are no negative solutions. Right? There are no negative solutions. So anytime we take a negative number and we stick it to an odd power, okay, it's going to remain negative. Even powers always make things positive, so please keep that in mind. Please let me know if you have any questions in class.